Look back at your notes. The first ones we graphed yesterday. Weren't those circles? So tell me about -6 cosine theta. It's a circle. What axis is it like on? Is it on the vertical or the horizontal axis? Horizontal, and I know that because it's a cosine, and cosine is x. And since it's a negative in front of it, it is on the left side. And what is its diameter? 6. So its radius is 3. Right? You need to be able to do that kind of thing. All right, now let's do the same thing with number 2. Number 2 is not a circle. Number 2 is a rose, one of the things with petals. Tell me what we learned yesterday about that equation. They're 7 long. So when we get around to graphing this, they're going to go out 7, right? What else do you know about them?
They intersect with the y-axis.
There's 3 of them. There's 3 of them. Right? Okay, let's plot just a few points there. Just a few of them. Those are special points. You should be able to plot those. And see if you can generate the rest of the graph based on the points that you have plotted. You don't need a calculator to do this. You can do this without your calculator. When you put in 0, did you get 0?
Yeah.
And when you put in pi over 6, did you get 7? No?
I didn't. I got 3.5 root 2. You got 7.
Okay. What's 3 times pi over 2? Or I mean pi over 6. What's 3 times pi over 6?
Pi over 3 pi over 6.
Which is?
Pi over 6.
Okay. And what's the sine of pi over 2?
Root 2. Oh wait, no.
The sine of pi over 2
That's
is 1 times 7 is 7. Okay. And I think that's enough. Because, remember, you already know the shape. This is a rose. And the petals are out 7. So isn't this a petal? And how many of them did you tell me you had?
3.
3. So how far apart are they? If there's 3 of them in the revolution, how far apart are they? Well, if we're in radians, yes, it would be 120 degrees, but that would be 2 pi over 3. So they're 2 pi over 3 apart. So if the first one is at pi over 6, where is the next one going to be?
5 pi over 6.
I have to add, right? Get a common denominator, 5 pi over 6. So the next one's over here at 5 pi over 6. And where's the last one? 5 pi over 6 plus another 2 pi over 3, which is, so straight down. There it is. And basically, we plotted 2 points. So you don't even have to taught to visualize these 2 points. We put in 0, and we put in the next one, pi over 6. And then after that, we knew what it had to look like because 3 petals, 7 units long, evenly spaced. All right, number 3. Consider the graph of this one. All right, how many petals does this one have? 8. Remember, if the coefficient on theta is even, it doubles. How long is each petal? 5. Where's the first one? Be careful. There is one at pi over 4, I think, but the first one's not there. The first one would actually be at 0, wouldn't it? Wouldn't the first one be at 0? Kids, what's the cosine of 0? 1. So the first petal is going to be out here, right here. There's the first one. Now, how many of them did you tell me there were? 8. So I've got 1 here, 1 here, 1 here, 1 here, and 1 here, and 1 here. There are my 8. How far apart are they? Pi over 4. That jives with my picture, pi over 4. What's the range? -5 to 5, yeah, -5 to 5. And what kind of symmetry does this have? So some of your shapes have symmetry, like think about the circle that you graphed earlier, look like this. It has symmetry about the horizontal axis. But what kind of symmetry does that have? Does it have symmetry on the horizontal axis?
Yeah.
Yeah, by the way, that's called the polar axis. This one is called the polar axis. Does it have symmetry about the vertical axis? Yeah. Does it have symmetry about what we used to call the identity line? Yeah. And the negative identity? This one has symmetry all over the place. This is like a perfectly symmetrical figure. All of your roses aren't like that. Like this guy right here. What does he have symmetry about? The vertical axis. Okay. Next page.
Did we do the angle between those?
Pi over 4.
Oh, yeah.
Vertical axis, horizontal axis.
For this one,
Okay, number 2 on the next page, page 9. We're going to do some more graphing. So your calculator should be in good shape. I mean, in terms of the window and everything. If not, you can make adjustments. But go ahead and type in these 4 equations. free system data. These are all examples of lima signs. We looked at one of these the other day. What do you notice about these? Okay, so they're all lima signs. They're all, I would say, oriented sideways. Would you say that their indentation is on the horizontal axis? But they have definite differences. What are some differences you noticed about them? Declan? So some of them have a loop on the inside, and some of them don't. So which ones have the loop? The first and the last? Okay, now, the other two did not have a loop. So it looks like if the plane number is less than the number hooked to the cosine, we're gonna have a loop. Would you agree with that? So when it says with 3, what do you notice when, number 3, when A is less than B, then it looks like we're going to have a loop on the inside. What was the difference between the first graph you did and the last graph you did?
One has like spacing.
One's facing right, one's facing left, and that makes perfectly good sense. These are cosines, right? If you have a negative cosine, you're going to be on the left, right? Okay, all right. Now what happened with the middle one? When the A and the B were equal, we talked about this the other day, what happened? You got an indentation, and where was the indentation? At the pole, and that shape is called a cardioid. And that's gonna happen whenever the two numbers are the same. One can be positive and one can be negative. All that will do is flip your heart, but they're gonna have a heart shape. What happened in the third one, the third graph? What happened there? It had an indentation, right? Indented, but the indentation was not at the pole. The indentation is going to be at the pole if it's a cardioid. If it's not a cardioid, you'll have that indentation, but it will be somewhere else, left side or right side. Okay? Now, let's do this. For number 5, before you go to your calculator, see if you can translate what you just observed with the cosines and freehand sketch the ones in number 5. And then after you've given it a shot, then go ahead and type it in on the calculator and see what it looks like. Now remember, these are signs. So what change is that gonna make? It's gonna be vertically oriented, right? But everything else you talked about is gonna stay the same. So see if you can freehand draw those two. Your scale might be a little off, and that's okay. I'm just interested in mainly the shape. Can you get the shape? you're done, go ahead and, go ahead and type them in on your calculator to make sure you're right.
This is for, I don't know if this is like, true for all of them, but like, it's like 3 plus 3 is 6. It's like 6 away from the original.
Absolutely.
It's weird.
No, that makes perfectly good sense. So,
Oh, yeah.
Cole has observed that when we have like this, that the farthest point out on the Lumason was at 6. And that makes sense because what is the biggest that cosine can be? 1. So the biggest this can be is 3. So 3 plus 3 is the biggest it can be. Yeah. So another observation maybe you made, maybe not, I don't know, is what about those ones, what was the, I lost my paper, 2 plus 3 cosine. We didn't talk about this, but that has an interior loop. Did you notice how wide the loop was? 1. Why do you think the loop was 1 wide?
Just what greater?
Because the difference between those is 1. When the difference between them is 0, there is no loop. It's 0 wide. So if this had been a 4, it would still have an interior loop, but the loop would be bigger. It would be 2 wide. Right? Now, what happened with your signs? They're up and down. Okay, that makes sense. Did the first one have a loop?
Yes.
Yeah. That was 1 big. Did the second one have a loop? Nope, that's a cardioid. And the third one, yeah, there's the origin of the pole.
But it didn't.
The third one yet doesn't have a loop, but it has an indentation, but that indentation is not at the origin, right?
So 1 away.
What, yeah, what was your farthest point for the last sign graph there? What was your farthest point? 5. 5.
This is making sense.
Yeah, I told you, the more you graph on, the more sense you have. Okay, let's do the back side. Number 1, we're not gonna do the whole table values thing. I don't need it. See what you can come up with in terms of the graph, just from your knowledge, freehand sketch, then type it in the calculator and see how close you were. maths, that's up to you. If you wanna stick in 0 and see what you get.
Yeah, just whatever, 4 up mine. Oh, wait, yeah. I just gotta guess on these last ones. Yeah.
One of those is probably wrong.
No, yeah.
Because then I was thinking, would it make you a
Hold
better?
on.
Like, it doesn't make sense.
What did you get for the first one, guys?
What for-
What was your thought when you looked at that equation? What did you think immediately? This is going to be a Lima sign, right? Gonna have a loop or an indentation, right? Which way is it going to be oriented?
Vertical axis up.
Vertical axis, right, okay. So, where did you have your indentation? Where did it turn out being? At the bottom? At the, yeah, 3 pi over 2, which is at the bottom, yep. Where the sign is -1, right? Good. Alright, so did everybody get something that looked like, I'm a terrible drawer, but did you get something that looked like that? For number 1? Okay. How about the second one? Let's talk about it just in general. It's a Lima sign. It's gonna be oriented on the horizontal. And is it gonna have a loop? No, it's a cardioid, so its indentation is gonna be at the origin.
One big difference between them is like greater than the amplitude of the sign. Is the loop gonna be like outside the circle instead of inside?
No, there's no loop.
No, but like, if there were.
It would be like an reaction. This is
Like, it just looks like it's trying to complete a circle. Like the closer the difference gets to,
the more,
like the more it looks like a circle. Like on the.
yeah. Okay, so what did that one look like? Which way was it going? Was it a heart going like this way? Or was it a heart going like this way? I know it's one or the other. Which one was it? I think it was this one, wasn't it?
Yeah.
Going that way? Remember, you aren't gonna have to create an entire curve on your own by plotting a bunch of points, but you are gonna have to recognize features of the curve. Avery? Why didn't the negative in number 2, so -2 plus 2 cosine? Now, what do you mean, why didn't it change it to what, Avery? What were you thinking that was gonna look like? Okay, say that again. Oh, no, be careful, we aren't multiplying by negative. We're adding negative, okay? So if you multiply by negative, just like with your circles, that flips you. But when you add a negative, that just picks you up and moves you up. So it just moves each point, okay?
I graphed both because I was confused on the calculator for number 2, like -2 plus 2 cosine and then 2 plus 2 cosine, they were the same. Like, did I do that wrong or are they supposed to be different?
You got, what did you do now? Tell me again, I missed part of
Like,
that.
the one that you just wrote up
Yeah.
there and then also 2 plus 2 cosine
Oh,
data.
so Declan says he graphed, oh, positive 2. This here, is that what you said? He graphed those, and they came out to be the same. That's kind of weird. Is there a reason for that, do you think? Well, let's plot some points and see, because the points are gonna end up getting plotted in the same place if, indeed, these give us the same value. So, let's put in 0 for this equation right here. If I put in 0 for theta, so I'm plotting points, r theta. If I put in 0 for theta, what's the cosine of 0? 1, and so that would be 0. Would you agree with that? Okay, so now I'll do this one. Let's put in 0 here. I get 4. Shoot, let's try pi. What happens if I put in pi? If I put pi in here, this would be -2, so I get -4. Now, what's another way of writing the point -4 comma pi? So, they are the same equation. They are exactly the same equation. Because here, if I put pi in this one, I would get 0, which would be the same as the point 0, 0. It's weird, isn't it?
Yeah.
Do you think it happens with sine? Try it. Graph -2 plus 2 sine, and graph +2 plus 2 sine, and tell me if you get the same thing.
I've never. You've seen how bad I'm
It's a great observation, by the way, Declan. Do we get the same thing?
Yeah.
Are those exactly the same?
Aren't they the same?
Yeah.
Well, when you accelerate, you graph them on top of each
Well,
other.
I see, we see it, but they're like different, but it's weird.
Yeah, so that's what we're talking about. Declan observed that and thought, what in the heck? So I got both of them at the same time. And they're right on top of each other, right?
So, that's an exception to like the A is less than B rule.
What?
You said A is less than B, you had like a loop inside.
Yeah.
So that,
Are we okay with that? All right. That homework, I said we're gonna be due tomorrow, right? So we got that under control. All right, let's get out our new notes. Actually, we only have 4 minutes. Let's not, does anybody have a homework question?
Yeah.
From 3.14? We can look at right now. Olivia?
Can you do the last one?
I don't know, can I do it in 4 minutes?
Anything's possible.
Number 7?
Well, it's number 7, but it's the graph.
Alright, so that, I'm confused here, that graph is right there above it, right? Okay, so the figure shows the graph of the forward function. Okay, the points are labeled, okay. If the domain of f is restricted to pi over 2 to 3 pi over 4. So instead of looking at the whole picture, we're only looking at that part. The portion of the given graph, okay, so 2 pieces of the graph. One is going from D, is E the origin?
Yeah.
All right, so one is going from D to E. What is the other part? Now, I'll tell you what my absolute gut feeling is, especially after just graphing a whole bunch of these things on my calculator. That loop, that curve is coming up from D to E, and it's gonna keep on going in a nice nice smooth piece. So it's gonna go to, from E to A, is that A over there? So think about, you're following the curve, so he says you're going from here to here. Actually, you're going. Cole, I need you. I'm terrible at this. Okay, so I'm connecting, this is all one smooth curve, Olivia. So if I am going from here to here, my pencil is moving like this, it's gonna keep on moving and go to here next. And then it would go to here next, and it would just keep on going, just like that, all the way around.
Now it makes sense, cause
Okay.
I was.
Now, we can do it, I don't remember, yesterday I think I did it maybe with a rectangular curve, so I could graph that same equation, 6 cosine 2 theta. I could graph 6 cosine 2x and watch it in a rectangular system.
What's it?
Praying.
Lord, thank you for the food for us, the Irish family and friends beside us, and the love of you. Give us the desire to pray. Bless the Lord, these I gifts, which we are about to receive, and I vow to your Christ, our Lord. Amen.
Tomorrow is 3.15.
Like I might be dying. It's so good.
Well, go ahead and grab it. Grab like this. And you will see where your cosine. Go ahead and grab it.
That is where.